Good evening. I'd like to introduce our guest, Sarah. Sarah is a graduate, an alumnus of University of North Carolina, and works for Microsoft.
Hi, Davis. Thank you so much for the introduction.
Hi, Sarah. For those of us not familiar with visual cryptography, please tell us about your research. Could you please give us a layman's explanation of visual cryptography?
So think of visual cryptography as a secret sharing scheme, but add visual to it. Now, we all know that in cryptography, you have to do a lot of complex computations that humans by themselves are not able to perform, and hence we use machines. Visual cryptography, as the name kind of suggests, uses the human visual system to do decryption of messages. So the way this works is, say, for example, you have a message, and your message is represented as an image. Now, traditionally, visual cryptography was originally, envisioned, the idea was envisioned in the early 90s. And the way they came up with the idea was, think of the message as black text or a black image on a printed transparency. So what you do is you take that message and then you kind of split it into two different images. So like your original message is in an image, then you split it into two more images. And now if you look at these two images, the way visual cryptography splits them, each individual image that has been split, we refer to it as a visual share, makes absolutely no sense. It looks completely like noise, and you cannot learn anything from that. Now, however, think of these as these two visual shares, both on printed transparencies. Now you take one of them and you physically overlay one transparency on top of another. And when you do that, you can see the final message all over again. So that's the general idea behind visual cryptography. What we suggested in our research was, how about we take this idea of overlaying one transparency on top of another to augmented reality, where the idea is that you overlay information on top of the real world. So take the exact same concept, you have a secret message in the form of an image, you split it into two parts. One of the parts resides on an augmented reality device, could be Google Glass, could be Microsoft HoloLens, or like a number of other. The other visual share or the other could be printed or it could be displayed on a different. And when you overlay one image on top of physically, like you're wearing your glass, you take it over, like physically overlay it on top of the other again. The cool thing about this, when you're doing this, is that you're not trusting more. So that kind of is, I hope that makes sense.